So good afternoon, everybody. Welcome to the speakeasy session of Introduction to Temporary Power with Rich Rayner from Figure of Eight Events. Just a couple of housekeeping things. If everyone could just make sure you're on mute. And then if you have any questions, I'm sure that Rich can answer those for you. And he'll just explain a little bit about that. Just to make you aware, this session is being recorded, as we'll be using it on a playback online for anyone who wants to watch it back later. Okay, so have a great time.
Thanks, Meg. Sorry, folks, just bear with me 2 seconds while I reinstate my screen share.
I've got a bad back at the moment. Couldn't get a table in the restaurant. Couldn't get a table.
I think someone's got their mic possibly unmuted.
Outside, you know, I sit outside, don't go inside. Same house.
James Ross, can you mute, please? Thank you.
Sorry, folks, apologies. I've just lost the connection to my iPad a minute, so I'll be with you in 2 seconds. Video was never my strong point. Sorry, I think it's an internet connection issue. Just bear with me 2 seconds. Sorry, folks. Technology, hey? No, this is not happening. Sod's law, you try things 3 times and it doesn't work when you actually need it to. Apologies. Right, we might have to do this slightly the old school way. Let's see if I can get this.
Do you want to email me the PowerPoint and I can do it via my laptop?
Yeah, do you mind, Meg? Is that okay?
Yeah, no, it's fine. Yeah.
It's a keynote. Have you got keynote?
Yeah.
Amazing. Sorry about this, folks. Meg and I tried this morning. I tried it yesterday and worked a dream. And it came to crunch time. It's distinctly failed, so apologies about that. You should have that coming through now, Meg. While Meg's just looking at that, I'm just going to give you a quick intro to today's session. So as the title suggests, it's very much an introduction to temporary power. For those of you who've got technical knowledge and have done quite a bit of this sort of stuff before, this is probably not so much for you, but you are more than welcome to be part of the session, of course, and ask any questions that you'd like to ask. But typically, I'm sort of looking at it with my video sort of specs on of how I would see video. I am absolutely terrible at video. I work with it a lot in the sense of powering it up and being around it, but I don't really understand it and don't really know a great deal about it. So I'm looking at it like that from a power perspective, a good overview for people to be able to sort of get to grips with the basics of temporary power. So I graduated from the Royal Welsh College of Music and Drama in Cardiff back in 2006 with a stage and event management degree. And I went on to work for, oh, here we go. Fantastic. Everyone see that? Just skip it back to the first slide for me, if you would, Meg. 1 second. I went on to work for a company called Power Logistics, who are market leaders in temporary power, and worked on a whole different range of events, from small scale fetes through to major public events and Olympic events. Yeah, it's been a real journey, really interesting journey. My sort of angle, if you like, is I feel like I'm not out and out technical, and I'm not out and out sort of logistics and sort of sales and nuts and bolts of sort of sorting it all out. I kind of sit somewhere in the middle. So I'm not a uber technical person, but typically my roles on site will normally be in understanding the technicalities of the power side of an event, and sort of relaying that to other people on site, and also making that happen on the ground. So we're just going to start very simply. We can skip onto the first slide. I feel like Boris Johnson. Next slide. Go on to the first slide. What is temporary power? So we can classify that in sort of three very basic sort of forms, if you like. I don't really class, you know, rocking up to an arena supply and plugging in your power locks for your art rack as temporary power. That's just sort of what we do, isn't it? But there are situations where we need to be able to plug up power, and that will inherently be outdoors normally. And I've kind of very broadly put them into three categories. It's worth mentioning that everything I'm telling you is based on my experience. It's not gospel. What I'm telling you is not in any way instruction to then to be able to go do something or be able to do electrics on site and so on and so forth. It's just my thoughts, my experience, and my opinion, if you like. So land mains is typically fed from the national grid. You would be able to go up to a supply, let's say Cheltenham Racecourse, for example. They might have some pillars or boxes there where you can plug your equipment into on site. Typically, you'll see on the left-hand side there the blue socket outlets there, the C-form outlets that you can plug into, and you could take your equipment, plug it in there, and away you go. Scenario 2 would be a diesel-powered generator. It's got an engine and an alternator inside, and you can bring that to site where perhaps you don't have land mains, and you can deliver your power through a diesel machine. The third option is something that's quite a hot thing at the moment and has been for the last number of years, and that's hybrid or battery units or solar, and that's whereby you charge up the batteries in that unit, and they're quite well suited to low demand environments and applications. We had a couple at Glastonbury a couple of years ago, and they're fantastic for powering low demand things that occasionally need a boost or a charge up. But we'll cover that a little bit later on. Typically, I find that the hybrid units are quite susceptible to damage. They didn't take particularly well to being trundled across a field and dumped on the floor with a forklift. So there's three different applications. They all have their limitations. A land main supply, of course, as we start to see our national grid now be more sustainable, using more renewable sources, could be deemed more environmentally friendly. But the issue with that is it's not contained within your control. So if something goes wrong upstream of the fuse board and it falls down to the electricity board, you could find yourself in deep water if you have an event whereby you can't physically operate. Of course, the diesel unit has its limitations too. It's a piece of machinery. It can go wrong, and they do go wrong, regardless of how well they're maintained. But it's under your control. So it's something you've bought in. It's your own environment. It's your own world. And you'll typically see a really good example of that is touring. So you'll quite often see venues that have the capacity in-house to be able to deliver the power that's needed, but because it's not in the bubble of being self-contained, a tour will bring in their own power because they can offer a backup, a redundancy, and it's under their control. They know what they're bringing in and what they've got with them actually works. If we could skip to the next one, Meg. Thank you. And I'm so sorry about the problem. I had my iPad with my pencil and all sorts of stuff lined up for you. So apologies that it's not worked. It's frustrating, but just bear with me as I explain some of the more technical bits. So where is temporary power used? I appreciate this is quite obvious subject for a lot of you, but we'll just skip over the headline titles. Festivals is a really big one where we do temporary power, typically because we're a million miles away from any substantial decent power. on a site map of a festival, you'll find hotspots of very big requirements of power needed. And the other thing, of course, is that the scope and the size of which distribution and cabling and power is needed is typically very, very big. You look at an aerial view of Glastonbury and it blows your mind. You just think, how can you physically get power to all those locations? And it is a challenge. It is a very, very big challenge for the team that do that, but it's possible, and it's all done in digestible chunks to make it manageable. So festivals is a big one. Concerts and tours is another big one. I touched on that just before when I was saying about generators being bought in. A lot of venues will have the capacity, but they won't have the redundancy. And by that, I mean, if it goes off or there's a fault with the grid, they might not have a backup generator. They might not have an alternative source. There are venues that do offer that. And with a bit of careful trickery, you can actually box quite clever and power big shows from stadiums and venue supplies. For example, Wembley Stadium has a switchover system between various substations that come into the building, and they use UPSs, which are essentially big batteries, to bridge the gap in supply. So if there's a failure, those batteries take the full load for a momentary minute of time before the systems can switch over to a backup substation and maintain the supply without a break in the supply. Similarly, the Principality Stadium in Cardiff has a backup system with a flywheel which constantly spins at the same speed as a generator. And if that power is lost, there's enough inertia and energy in that wheel to essentially keep the generation of power going until it can flick to an alternative source. So we're starting to see now venues actually coming up with ideas that are actually quite plausible to be able to offer backed up power. And that's backed up power to their building as well as the temporary supplies for concerts and things that could go in it too. Major public events and sports is a big side of our industry. Of course, the Olympics is the one that springs to mind, being the biggest, and those contracts are of course extremely complex. I was fortunate enough to work on both the 2008 and the 2012 Olympics, and the scale at which those things work is mind-blowing. Those of you who've done stuff on Olympics will know it's the sort of rule of 10. You think of it, times it by 10, and you're still nowhere near. The scale is mind-boggling at times. A friend of mine is working on the Japan Olympics, which of course was supposed to happen this year. And to give you an idea of scale and complexity, I think they're in the region of between 600 to 800 generators and around about 12,500 stillages of cable that they purchased specifically for the Olympics this year. So that's a real sort of, a big side of the project. The other part of it is on the sporting front, especially a good example is the Champions League final I worked on in Cardiff. Big project, but very, very geared and driven by sponsorship. So typically those power kind of contracts, the company that I was working for actually pulled out because the contract stipulated an uncapped liability for anyone to essentially sue the power provider if they lost power during the commercial break. So it gives you an idea of what's at stake and quite how pressure these environments can be, that there is no second chances and you can't mess it up. Winter events is another big one. Typically, the company I should have mentioned, the company that I run is based in Cardiff called Figure of Eight, and we provide a lot of technical support across the board: sound, lighting, power, staging, and so on and so forth. And we do a lot of winter projects supporting ice rinks and winter trails. That's another sort of key thing that people do a lot of. Sorry, Meg, if we can skip the next couple of lines, that would be great. Film and TV, and this sort of ties in a little bit. It's a little bit of a different world. Terminology is perhaps a little bit different. The equipment's a little bit different, but the principle is the same. I, until recently, worked a lot with BBC at Glastonbury. Unfortunately, there's too many commitments for me to be able to do that show now, which is a real shame because I enjoyed it. But bringing a TV production within a festival environment was really, really interesting because you kind of got the TV way of doing thing and the festival way of doing thing, and trying to bring all of that into one is quite an interesting beast. But film and TV, something I've got less experience of, and perhaps a little bit on the fringes. And just one other area, which is has been a big one this year, is what's been really good to be able to see is the temporary power solutions that have been rolled out throughout the pandemic this year. It's been amazing to see the speed and effectiveness at which we as an industry have been able to deliver temporary solutions for the COVID pandemic, because of course it ramped up so quickly. There was a need to be able to deliver quickly, and it was amazing. I worked on the hospital in the Principality Stadium in Cardiff, and we installed around about 12 megawatts, which is, to give you an idea, it's around about 6,000 kettles worth, if you like, of temporary power, which only represented, I think, about 10 or 15% of the power and air conditioning installation. It was huge, and it was amazing to see the speed at which we were able to deploy equipment in comparison to more permanent kind of hardwired solutions that would have been an option as it was all going through sort of construction company channels. So that was really great. All of this that we do is working to BS 7909, which is our code of practice that we work in the events industry, which we've really seen a real good drive forward on that. There's a number of people who've really been pushing that forward, and that's essentially a British standard to kind of establish and self-regulate what we do and why we do it. And of course, prevention is the best sort of course of action, really, for us to not have anything imposed on us that's unworkable. There's a British standard called 7671, which is the wiring regulations that doesn't really apply to our kind of world, but we've been inflicted upon us in the past. Various local authorities have said we've got to work to this standard, but it doesn't really work with temporary installations. It doesn't allow for the type of equipment that we use and that we put on the end of it. So it's really great that that people have been really instrumental in making that British standard really stand out and prominent within the events industry. Next slide, please. Thank you. Okay, types of power generation. So I'm just going to refer to diesel machines for the time being. Just going to give you 3 examples of generators, some generator setups. So this is standalone. It's just a plain old generator, diesel fired. It's got an alternator, an engine, a control panel, and a source where you can actually plug your cabling in to deliver your power. And it's a really straightforward, self-contained system compared to some of the other options that I'll show you. It gives you perhaps less fuel consumption, but it does have its drawbacks. There's no redundancy, and it has fixed capabilities. So unlike a hybrid unit, if you imagine turning your car on to charge your phone, that's constantly running. Whereas if we have a big battery and we suck power from it, we only take what we need. So of course, this generator only does one thing, and it will only be a 60 kVA or a 100 kVA machine. So that's standalone. Next slide, please. Another option is automatic mains failure, which is essentially whereby we take 2 generators and we both take them to, you see that blackboard there, apologies, I had all drawings that I was going to scribble out for you, that will go up to the distribution board, and they will common up at that one place. We then take a communications cable to one of the machines, which would essentially be our standby. That wouldn't run, it would just sit there. And then the machine, for example, to the left would run. Now, in the event of a power failure, the board will open the circuit breaker to disconnect it. It will then send a signal to the other generator to say that it's failed and that it needs to start. At the point at which it's reached 1500 RPM, or the speed that it needs to spin at, it will then re-engage the breaker, and then the supply will continue. It does have its limitations. It does provide a break in the supply, and you may not realize it's failed. So for example, a good example of this is you may put this on a festival and you might power some concession units and have that system there as some form of backup. The issue with that is you might have the machine fail, so the traders realize that they've lost power. but then the power comes back on within 20 seconds and they don't really think of anything. They don't think to tell anyone, and they just carry on as usual. In a very unlikely situation, if you're very unlucky, the runner or the standby machine then fails in due course over the weekend perhaps, or there's an issue with it and nobody's realized. And then of course you get the phone call to say, or the radio call to say, we've lost power, at which point you go to find 2 dead generators. So it has its limitations, and you might find that it's actually better to just have 2 generators side by side, with one running, with one connection, and then a connection sat there ready, so that if power fails, obviously that's less than ideal, but at least you know about it and you can action the mechanical fault and you can get it rectified. Next slide, please. Thank you. So perhaps a slightly more reliable way of working this would be to use what's called synchronized, and that's whereby both generators run simultaneously and they both cable into what's called a common bus or a distro board, which you can see above there. The cables run to that point, and then you put a communications cable between the 2 machines, and the control panels map what the generators are doing, and they essentially ensure that they're doing the same thing. This system provides a really good level of service and no interruption in the event of mains failure. Typically they'll be less efficient because you're running twice as many generators as you would be normally. And the other issue is that you might not know that you've actually encountered a failure, because it's seamless and the delivery of power will keep on going. You may have had a mechanical failure but not know about it. So you might have seen on festivals, perhaps the electrician behind the stage periodically checking the machines to make sure that there is no mechanical faults, and so on and so forth. The other thing you need to be very careful of is that you don't inadvertently overload the machines. For example, if we were to say that those 2 generators shown there could deliver 100 kVA each, let's say, that's just the term we use. It's a term of measuring the size of the machine. So that means that we can give 100 kVA backed up. So we can only deliver 100 kVA. But between the 2 of them, they will physically deliver 200 kVA because they're both running at the same time. So what we need to be very, very careful of, and this is sort of something we come up against quite often with changes in riders and so on and so forth on stages, is that despite the fact we can physically deliver it, we can't back it up. And by that, I mean, if we can do 100 kVA on both machines, we need to ensure that we don't go over that, because if there's a mechanical failure, the other machine will fall over and will be no better off than just having a standalone generator. So those are the sort of 3 scenarios. So you've got standalone, which is just a normal generator, AMF, and synchronized. If we could skip to the next slide, Meg, that'd be great. Apologies for the slightly wooden PowerPoint for those of you who've joined us late. I had some slight issues with my iPad. I'm ever so sorry. I had all sorts of wonderful ideas of pointing things out to you with my new pencil, which is not going to happen. So one thing I just want to touch on quickly is something called proportional load sharing, and this is for me brilliant. This is a really, really good thing that's sort of come in a little bit sort of not recently, but it's more of a thing now. And this is a really, really great thing to be able to offer clients who are looking to save energy. We were looking to roll this system out at Hay Festival this year, which is a job we do where we use we have kind of spikes of very, very high demand of the food hall and some of the venues, and then a very, very low demand overnight where it's just refrigeration and site lighting and things like that. So what proportional load sharing allows us to do is to take the same scenario as what we had before. And bear in mind, this doesn't have to be 2 machines. This could be 10, 4, 6, 8, you know, whatever. But it allows you to take a number of machines of one size and then add, if you just skip to the next slide, Meg, I think it brings up a little generator. There we go. To add another generator of a smaller size and link them similarly as we have done previously into one common bus, the distribution board you can see there. And you can actually program the panels to all of them work as hard as they can when they need to. But then at times when the load's very, very low, typically overnight, that the larger machines would shut down and the smaller machine would just maintain the load overnight. The good thing with that system is if that small machine then had a fault, one of those larger machines would be called upon to be able to start and deliver the power to keep it going. Of course, there would be a break in the supply, but typically that doesn't matter too much if it's only doing site lighting, refrigeration, and it just means you won't come into a melted ice cream or something in the morning. So that's proportional load sharing, and that's a really, really great thing that you can ask your power provider to explore for you on events, and it's it's a really great way of working. So that's that. Next slide, please. So other types, we touched on hybrid. Oops, skip back, Meg, we've overshot. Where hybrid really works for me, and I think is fantastic, is in some of the specific environments on site. Hybrid for me won't work where you've got big block loads. For example, a couple of years ago, we had Kanye West playing on the Pyramid stage at Glastonbury. 1,000 par cans, an immense load, probably the most I've ever seen, dumped onto a generator at once. And it was quite scary, really, to see generators work that hard. We're not used to that in this day and age of LED. It just doesn't happen so much anymore. So those generators work very, very hard. Where the hybrid units perhaps are more suited to is in environments like site offices, where you have, much like I was saying at Hay Festival, on a smaller scale, you might have environments whereby you might have bunker bins. So the temporary accommodation units that we use on site, you might have a village of contractors at, say, a plumber's compound. They all come in at 6 o'clock, they all need a shower, and they want to get washed and dressed and changed, and they're all putting the heaters on. The demand there spikes right up. And then once they go out in the morning and they go to work, there's literally, the consumption is virtually nothing. A couple of immersion heaters perhaps, but it's minimal. What you can do is you can put a hybrid unit in place, you can put a generator alongside it, and then you can use the generator to charge that battery and also use the generator to deliver that hit of power that's needed at those points. And for the rest of the time, the battery will just take the load. So in terms of fuel savings, it's really, really, really quite remarkable what you can do, especially over long periods of time. Where they come unstuck slightly at the moment is that the hybrid units are incredibly expensive to buy and therefore incredibly expensive to rent. So we're not perhaps there with the economies of it all, but the principle, I think, is really exciting. Next slide, please, Meg. Cabling. I'm just going to touch on this really, really quickly because I know for a lot of you, you'll have probably experienced this, specified this, seen it, so on and so forth. But again, as I said, this is an introduction and I just want to go from the sort of beginning as much as I can. Connections we use in events vary greatly. There's loads of different connectors. There's lots of connectors that we don't use anymore. There's different types of film and TV. But typically you'll be used to seeing these sort of connectors on site. So the one at the top there is a 16 amp. You'll notice it's got 3 pins, which is much like your 13 amp plug at home. And that's a live, a neutral and an earth. You may then also encounter and come across 3-phase connection, which is the same sort of thing, but it has an additional 2 phases. So it allows us to essentially run more power, perhaps for further, because it runs at a higher voltage. So therefore we can run it further. And then in a very large sort of environment, in fact, you'll see that the watermark picture behind shows this. We'll use single core cables. So in the example of the red connector there, all the cables are inside one. And then there comes a point where that becomes unmanageable because the cable would need to be so big to house all that cable. So we then go to the connectors you can see on the bottom of the screen there, which is called power lock. And that essentially splits all of those individual cables out into separate ones so we can physically manage them. So when you're seeing stadium kind of gigs or shows or festivals and you're seeing that cable, that's the kind of way it's distributed. Next slide, please, Meg. Distribution. So how do we physically get from our generator or our source of power? We want to be able to get to our end sockets, if you like. We do that through the use of distribution boards, and that's essentially a kind of a backwards funnel, if you like, taking typically in very sort of rudimentary form, something big to lots of small things or smaller things. So in the example of the one on the left there, that's quite a small board. That's just a 32 amp feed that's going to multiple 16 amp feeds, whereas the board to the right is much bigger. That's something you might see sat perhaps behind the stage or in a broadcast compound, and that gives you some small feeds, but also gives you a variety of different feeds. We saw the 32 amp connection there. You've got 63 amp and 125. And it basically gives you a number of different outlets to be able to then have further distribution boards split around and so on and so forth. We skip on to the next one. It's imperative that when we use distribution boards, we have adequate circuit protection. And that's through MCBs and RCBOs typically. MCBs protect the equipment. They protect you from melting the cable or melting the distribution or equipment. RCBOs protect people, and you can typically recognize those by the little test button you see just below the red line there. That means that that has some form of RCD protection. Doesn't necessarily mean that it's fitted for what's called personal protection, which is 30 milliamp. You might have heard that term, but that's for protecting people. We should always ensure that final circuits have got 30 milliamp protection to protect people. So MCBs protect equipment, RCDs and RCBOs protect people. Next slide, please, Meg. So as great as that is, having RCDs in systems, it does present some problems. And I invariably get questions from clients saying, oh, when you do our power, we always have an issue, then something trips out, everything goes off. And that's something really important to look out for. And perhaps if you're specifying power or you're asking people for quotes or advice on stuff. I've just taken a little screenshot there of quite an old distribution unit, which shows there is an RCD present. You'll see it says RCD there on the screen, which means it's protected, which is fantastic. It's really, really good. It means that it's protecting people if there was an electrical fault. The issue for us is that if, for example, you see the circuits there, you've got a number of MCBs which protect you from overloading the circuits. If, for example, any of those were to encounter a fault, you'd lose the whole board. And that's what we get from clients. They say, everything goes off and we lose the whole system. So by using, let's say in that example, we've got 6 MCBs and 1 RCD. What that means is that if we get a fault, we lose the whole board. So when specifying and looking at distribution and how it works, it's really important that for the vast majority of applications, we're doing what I've shown on the bottom there, which is a row of RCBOs. So in the event of a fault, an isolated fault on a circuit, that you'd only lose that feed. So in a real life environment, if you lost the whole thing, you might lose your sound, your lighting, your concession unit, whatever, in a small scale. So it's very important that we're able to offer that segregation there to be able to make sure the show can continue to a greater extent. Next slide, please, Meg. Testing and qualifications, ooh, big topic. So I mentioned before BS 7909. Oh, go back. That is the code of practice that we work to in our industry. And it's really, really great because it allows us to have a framework to work within. Most local authorities now and people will expect you to work within those parameters. And it's quite good to see that that's kind of seen on documentation and that's recognized. And like I said before, it allows us to apply a specific framework to our events kind of model, which doesn't necessarily follow the same model with buildings and construction and so on and so forth. Being qualified and being experienced is a really interesting thing, and that's kind of follows on from what I was saying about my experience. I don't have any electrical qualifications, which is quite interesting, but there really is a kind of opportunity there for everybody to be able to play their part within designing and building systems and distribution. Some of the best electricians and people on site on temporary installations I've encountered have been qualified, and some of the not so good have been qualified. So for me, I think it's all about understanding your limits. It's about training where applicable. And if you are in an environment where you are installing and working on temporary installations, you know, on the tools, it's important to have suitable qualifications. Next slide, please, Meg. Fuel, just skipping back then. Now we've covered a bit about distribution. Hope that all makes sense. It's all okay. At the end, do feel free to ask any questions. But we're just going to cover fuel quickly. Fuel typically comes in 2 sort of formats. There are some variations which are perhaps sort of less widely available. Typically, diesel, gas oil is the most commonly used, and it's sort of relatively cheap as fuel can be. But it does have quite poor environmental credentials, and it's kind of sparked new conversations about another fuel. If you could skip to the next slide, Meg. Thank you. And that's biofuel, which is also known as HVO or Green D+. I was fortunate or not fortunate enough, I don't know which way you look at it, to work on some systems in the early days of when this sort of started coming out, and we ran a number of events on some of the early biofuels, which was refined using ethanol, which we discovered was quite an evil thing, because it stripped all of the previous deposits left by diesel in all of the generator systems, in typical diesel generators, and dumped them in the filters and created a lot of blockages. So it was quite a high maintenance kind of product. We also ran some winter events on the early biofuels. That was a recycled chip fat product, and we had a lot of issues with it at cold temperatures waxing up. So we had to use electric heaters to melt the wax and the fuel, and it was yeah, it was really quite hard work to work with. But this was quite a long time ago, and things have moved on a lot since then. Some of the newer vegetable oils are now refined with hydrogen instead of ethanol, so they're much kinder to generator sets. And you'll find that a lot of manufacturers, diesel generator manufacturers like Volvo, Perkins, Cummins, and so on and so forth, they will actually warranty and will allow you to use those fuels in your machines, and they benefit from some really good environmental credentials, but they are quite expensive. Next slide, please, Meg. I'm just going to go on to talk, and the next one again, about some of my kind of golden rules in closing before we go to any questions, about the way I tackle things and the way I look at stuff. And these are kind of in my head, the golden rules of what I do. And that's sort of three things that I stick to, and that's specification, communication / team, and diversity and reliability. So to start with specification, for me, I found it over the last 10 years or whatever, really, really interesting looking at how other people are trying to bring in new power generation technologies and processes. And it's amazing to see, like I said before, with the hybrid units, they're really, really great. But for me, it's not the starting point. The starting point is about specification. And this is the thing that infuriates me day in, day out, is about keeping it tight. It's really, really important that you push your suppliers for accurate information. If I had a pound for every time that I was told I need a 125 or I need a 63.3 or whatever, and you get to site and you realize that that supply has not been fully utilized at all because it's just what their distro has or whatever, because we're not privy as the power provider to the inside workings of what's happening, you know, with the lighting design or the sound design or the equipment on site. It's really, really difficult to really sort of tighten that all into something really, really sensible. So invariably we end up with a situation where either we're doing the pushing or we're doing the asking questions to get that information, or we end up over providing. So for me, it starts, you know, being environmentally friendly and really pushing our carbon footprint down and our costs down on fuel consumption and so on and so forth. Really comes down to specification in the first instance. Communication and team. And I say this with a pinch of salt. You don't have to be technical to play a part in a team of site power. To do certain roles, of course you do, and that's not a carte blanche, permission to go do whatever. But it's really important to understand there's so many different people involved in the process, especially on some of the larger events, where everybody can play a role. On the hospital in Cardiff, I dealt with pretty much all logistics within a power team. So I'd say to those of you perhaps who are watching this and thinking, oh, I'm not a technical person, there is space and scope to be able to have a really important and valued role within logistics, design, communication. So much of my time is spent in liaison, in crew planning, in planning the right person to go in the right role and judging characters and all that sort of stuff. And it's vital, especially on the larger events, that you have that multi-skilled team. And I think people all too often make the mistake of thinking it's purely about technical roles in delivering a really good temporary system. And lastly, diversity and reliability. The system designed always, in my eyes, needs to be focused around the what ifs. I think all too often in the events industry, you know, we see an outlet, we see a hole, we plug it in, we don't, and it works, and that's fine. But what happens when it goes wrong? Is it safe? Is it reliable? Is there any diversity there? And by that I mean, for example, I did a site visit a couple of years ago, and this one sticks in my head. It was a double deck structure on a golf job, I think, that we were looking to take on board. The supplier not particularly performed overly well, and as I walked into the structure, it was a 80-meter by 30-meter single span double deck structure with a tack off lining, custom made, Rolex watch sponsor kind of thing. It was pretty pucker. The electrician had wired a seemingly simple part of the installation upstairs and had not put the sump pump on the same feed as the dishwasher in the bar. So with it being upstairs, they need to take the excess water away from the dishwasher and pump it out of the building. They put it on a separate feed. The sump pump had tripped out through a fault, and the dishwasher had not. It spat dirty plate water all over the upstairs floor, which leaked through into the downstairs floor. And that was literally a 2-second decision in their head of, there's a hole, plug it in, stick it in, off we go, bang, 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 bang. And the consequences of that were that you had a single piece lining that needed to be replaced that couldn't be. So it's understanding for me the impacts of what if all the time. And that's really, really important. And it's what fills my head most of the time, is understanding what happens if this goes wrong? What have we got up our sleeve? What's the backup plan? How are we going to get around this if it happens? Because believe you and me, I've been in that situation where it does happen and things go wrong and you haven't got those things up your sleeve, and it's a very scary place to be. So those are my 3 kind of things. I hope that's some sort of help and use to you, but I just wanted to share those with you as some form of guidance in my sort of rationale of what I go through. Has anyone got any questions at all?
There's a couple in the chat, Rich. Have you got the chat? Do you want me to read them out to you?
Okay, so Simon Barrett. Hi, I have 2 questions. 1, when specifying RCBOs, are you using 100 millisecond ones rather than 30 milliseconds? What is RCCB in comparison to MCB and RCDs, RCBOs? Okay, Simon, I've got a really good document. I'll answer your first question on specifying RCBOs. On the second, I will send you a document that I've got that's really, really good crib sheet of breakers and so on and so forth. If you could just either contact me on social media or send me your address and I'll send that across to you. It's really, really helpful. We use them quite often. When specifying RCBOs, are you using 100 milliseconds rather than 30 milliseconds? It's solely dependent on the installation. We use instantaneous for final circuits, but it is totally dependent essentially on the design and specification of the system. I can only see one question on there. Is there others?
It was the 2 from Simon on there.
Oh, okie dokie. Yeah, Simon, please do feel free to get in touch with me, and I'll send across some crib sheets that I've got of those things.
I've got a couple as well.
Go for it.
BS7909. So is that something that is required for if you're just putting in a generator and plugging in cables and no wiring or anything like that is required? So basically that everything is pre-existing sealed cable. Is 7909 required as for the company that is installing the power, or what's the?
I would say so, yeah. I mean, that's my understanding. A lot of our guidance tends to come from something that's stipulated by local authority. But for me, all too often, I think people can get far too carried away with what I was saying before of we see a hole, we plug it in. And that's the inherent danger in our industry, I think, is people not fully understanding the consequences of understanding the design in its environment, and that kind of ties in a little bit with the whole pat testing thing. That we can have a piece of equipment that's safe, but if it's used in an unsafe way, it can be really dangerous. So there really is a need there to kind of put ourselves under scrutiny to make sure that what we're putting in and what we're doing is safe in its environment, and that goes from connection to cable distance, volt drop, and so on and so forth. So yes, I mean, I would always say that that's important. We do that, and we actively try to do that independently. So we use a number of people who kind of don't work for us almost, pardon me, and they scrutinize our work, and they're really great at it, and that they'll pick up things that say, oh, well, you know, have you thought about this, or have you spotted that? And it's as much about having a second opinion, if you like, as anything else.
So it's maybe more about the design and the thought process about how the things are used, rather than two people, you know, somebody has the ability to plug something in. It's not relevant to that. It's more about the planning, I guess, even if it's on-site planning of what's used. Right.
Yeah, I really firmly believe that.
Great. There's a couple more appeared in the chat as well.
Oh, great.
Rich, do you want me to read them to you?
Oh no, I've got them. I have the technology to do that. I couldn't give you an iPad, but I can do the. Okay, Tanya, do you have any suggestions on good resources to learn more about temporary power from? Yes, again, do feel free to share your email, send it across to me separately if you want, or find us on social media. There's loads of good stuff out there. Anything by James Eade is really good in my opinion. He's a great guy, and he's been really pivotal in sort of pushing that forward. And he has a lot of really common sense like approaches to things. If you can, a BS 7909 course is really good to do. There's a number of different people that run those. I think Gavin Plaza do have some connections. You know, I think they do. There's I think Pierce Hire run some, and Beck2 do as well. So yeah, really great course to take people up on, and focuses a lot more on the sort of technicalities of stuff. Harry, hi, earlier you referred to the TV way of doing things and the festival way of doing things. Could you elaborate on that? Oh, yes. I can't elaborate on that a great deal because I'll be totally honest, I don't do a massive amount of TV. But I'm sort of referring to the terminology more, I think, is always quite a challenge. TV people call things one thing and we call them something totally different. So yeah, it was nothing more than that.
Rich, I have a question.
Go for it.
If you're not necessarily a technical person,
yes,
like myself, but quite often maybe you're a project manager or someone that maybe is responsible for booking suppliers, would you say it's fair to say that you could ask your power supplier for suggestions on how you would get power around your site or your venue, and you're happy for it to be more of a basic conversation rather than using very long and technical words that I certainly don't know?
Yeah, and I think for me, I mean, rightly or wrongly, I think it comes down to judge of character. You know, when you're approaching a company to engage with them, to work with them on a project or projects, you know, I typically will get a steer for how switched on they are and how au fait they are with what it is they're supposed to be doing. And I think that there's a lot to be said for involving your power supplier in conversation. If you have the confidence that they know what they're doing and that they are experienced and suitably, you know, qualified, I would say it's better to involve them, because you don't understand the inner workings of their equipment, what they have available, how they configure it. And quite often for me, when I get production managers who give me everything, all the information, it's sometimes more difficult because then I've got to divulge that and translate that into our language of what we've got and how we would do it. So quite often it's actually more helpful to get the bare bones information accurate from a customer, for us to then be able to put that into our language and work out the most suitable solution. But yeah, I mean, I always think the first thing is judging people's ability from the outset and the suitability of their company, and all the seemingly sort of trivial other bits that go with it about the company's support network and how they operate, and what happens if John Jones, the manager, gets run over by a bus, and all that side of stuff, you know, is all really important too when you engage with those people. Anyone else?
I'll jump in. I've got a stock of them, so I'll keep going. So one of the very should be a very short answer, I should imagine. But with the hybrids, you showed something where there was a hybrid with the generator to charge the battery when or deal with demand. Is that on a similar thing to how the AMF was, that the generator wouldn't be running, but it'd start up when required, or would it be constantly running in the background there?
No, sorry if I didn't explain that very well. So the idea is that the generator only runs when it really needs to, and those two scenarios would be a big increase in load. So the hybrid unit would have thresholds set on it whereby it knows it can deliver, let's say 100 amps, 60 amps, and you can set this to whatever you want it to be. When it sees that load incrementally start to increase and goes, uh-oh, we're starting to get into shower time here, it then sends a signal to the generator to directly boost the supply and not totally deplete the battery within 2 seconds. So yeah, so the two scenarios would be generator comes on to provide good chunk of power for a short time, and the other scenario would be generator comes on to charge the battery quite quickly.
Great. I'll let you go to chat before I ask my next one. There's another appeared.
Ah, Heather. Hello, Heather. Hey, similar to Meg's question, any advice on writing power specs for site when often people running certain elements, bars, concessions, etc., can't give accurate specs? Yeah, this is a really good one. This is a really good question, and it's I don't know if there's any answer to it. If I'm honest, I typically find that we can gauge a lot of the peripheral stuff with a fairly broad stroke, and most decent power providers should be able to do that for you. So in the example of Bloodstock Festival, for example, which I know is one of yours, Heather, Frisbee, your power guy, will know that concession island there will be 100 kVA. You know, pretty much come what may. If you can't give us a spec, we should be able to do that. On the spec stuff for stages, that's where we really need to nail stuff down. And really, if the lighting and sound contractors you're using and so on and so forth have done their prep and their calcs to tell you what we need, we should be in a position to have those conversations with them direct, if that's appropriate, to be able to really nail it down and really get to the nitty gritty of it. You know, and we do that quite frequently. Customers will say they've asked for this, but it doesn't feel quite right. And then when you talk to the supplier and you get to grips with what it is they exactly need, you realize that actually, you know, you can bring that demand down, and you can actually, you know, push it into a smaller amount of generators or a smaller supply. But yeah, it's a really good question. There's no sort of hard and fast answer, because it's the world we work in, isn't it? But I would say it's stages particularly we tend to have the majority of issues with. Final call. Anyone else?
Me again. So for me, I'll do this as the last one. So the three-phase, in a three-phase scenario, there's always talk about balancing the phases, and I always nod and smile and know that that's important. But that's as much as I know about it. So why and what do you have to do to balance the phases?
Okay, so typically on a distribution board, in a normal scenario, phase balancing only applies to three-phase loads. All right, so anything that's single phase, it only has one live conductor. It's not applicable really. Your only concern there is overcurrent. And so in a three-phase system, predominantly for consumption, really, if anything, the importance of balancing phases best you can. And I would say it's probably easier now, from my experience recently, than ever before to do that, because we've got more LED technology and things are generally a bit more stable. In the oldie days of racks of par cans, that was obviously more difficult to do, because you'd balance it to one song and then it would all change the next. So it's quite difficult. You could only do that on a full load. But typically the first and most important sort of consideration is phase balancing for consumption, really. That's predominantly the main reason. You can start getting disparities in your neutral current, because there's of course always a current present in the neutral when you've got imbalances in phases, and that can create issues if you've got circuit breakers that break the neutral as well. But yeah, it's actually less of a thing. I come across it less often now, Gavin, than probably we've come across before, simply because of the technology tends to be a lot more stable now and a lot more just sort of, you know.
Okay, thank you.
Super. Folks, I'm so sorry about my iPad. I'm gutted. I was gutted I didn't want to use my pencil, and it would have been a lot easier for me to be able to show you some of the things I wanted to show you. But yeah, thank you ever so much, everybody, and I hope it's of some use to you. If I can help at all in any way, give me a shout, and if it's something I don't know the answer to, then I'll gladly put you on to other people I know too. But yeah, thanks ever so much, and thanks ever so much for We Make Events for putting this on. It's fantastic.
Well, thanks very much to you for putting it on. And I wonder whether some of the follow-ups, whether you would be potentially available in Discord if people had some questions or anything, or sharing documents and getting in touch with you through the.
Absolutely. Yeah, no, absolutely.
Yeah, might need to give Rich a little rundown of Discord, but yes.
I see he's on there though now.
I'm on it.
He's on it.
Yeah, at the moment.
Not sure what to do.
But seriously, the door's open. Look us up online, Figure of 8 Events on Facebook, and get in touch if we can help in any way. Honestly, it's not a problem. The more information sharing and knowledge we have between us, the more we can work towards safer systems, I suppose.
Lovely. Thank you very much.
Thanks, one and all. Take care. Bye.